Another type of map that we can make with points, and in this case I would think of almost pinpoints, very small little points, is a dot density map. On a dot density map, each point represents a certain number of items. It could be a certain number of acres, or a certain number of people, or a certain number of voters. These dots are randomly distributed within some area in which a number is known. So it might be the number of people that voted within a certain voting district, or the number of people that live within a certain census tracts. With these dot density maps, because the dots are randomly distributed within that area, no individual dot reveals an exact location. So this kind of addresses one of those issues of privacy where it looks like a very detailed map, but it's really based on a random distribution within smaller known areas. And the nice thing about these dot density maps is the overall distribution of the dots shows the pattern of whatever you're trying to show on the map, whether that's population density or something else. And of course, the other thing about those dots is then they can be represented either as a single color, or they can be represented as, for example, different colors. We don't typically vary the size of the dots on a dot density map, but we can vary some of the other visual variables. Here's a dot density map, which is clearly indicating that most of the good cropland in the United States is in the Midwest. So we can see that, of course, there are crops in the Great Valley of California, in the Willamette Valley, and other places, but most of the crops that are grown in the United States are kind of in the country's breadbasket here in the middle. And in this case here, each dot represents 25,000 acres of cropland that is harvested. So each one of those dots is not exactly above a particular plant or a particular field, but it's spread out based on how much cropland is within each state, and then, or I think in this case, each county, because we can see that the patterns across the state vary here, and then putting those dots randomly within each of those counties. Here's a dot density map of where malaria cases are in Africa. And this kind of runs into that problem of, well, if we distribute all of those dots within an area, such as a country, like this country here, then they're just randomly distributed throughout that area. In truth, because we have a tropical area here and a desert area up here, the Sahara Desert, it probably more closely matches where we have boundaries near the edge of that, such as here. We have a lot of malaria cases here. We still have some here, but I would guess most of those were to the south part of this country. And if we have a country that extends through both of those, once again, I would assume most of these malaria cases here are going to be in sub-Saharan Africa, in this location here. So when the dots are distributed randomly. If that is a good assessment for the entire country or state or county, that works very well. But if it's not, we might see some artifacts in the map, like these dots distributed throughout the Sahara Desert, even though the malaria is probably only occurring in a portion of those countries. Here's a dot density map of Oregon showing population density. So in this case, each dot here represents where 250 people live. So areas that have a lot of people, closely spaced, get very bright, and those areas where there's just a few people living in an area less than 250 people, then those areas, each dot would represent 250 people, so that would be one grouping of 250 people. Once again, that doesn't mean you can zoom in and see their house, right? It just means within this area here, there are approximately 250 people living in order for them to get that dot. And one of the things we can do with this, instead of making everything one color, if we wanted to see, for example, where the youngest and the oldest people lived in Oregon, we could use two different colors. And in this case here, one purple dot represents 50 people age 5 and under, and we can see they're really kind of distributed around the suburbs, right? Or the suburbs of Portland and all the other cities here. And then where people 85 and older are, they're kind of in the heart of things. They might need medical services or have an easier time getting around in places where there's a lot of other people living around them, so they're distributed through those areas here. This is another dot density map where one dot represents 10 votes in the presidential election. And we can see this is kind of nice for two reasons. Ken Fields is using two colors here. Red and blue. Red is typically used for Republicans, blue is typically used for Democrats. But because there are so many dots on this map, we're actually seeing a lot of color blending here. So some of the areas are red and blue, and some kind of give an indication of purple, but we can see all that sort of blending of colors. But even though you can't even see the individual dots on this map, we still get these colored areas associated with this dot density map here. And one other example, this is the Greater London area, and this shows where where people have identified themselves as different religious backgrounds. So we can see now it's not just two colors, right, which lend itself to nice color blending. Here we have a number of different colors. Christian and Muslims are making up the majority of it, so we get a lot of bluish areas and greenish areas. But and there is a lot of clustering here. So for example, these yellow areas here would be Jewish areas. But also some of the colors are blending in. I'm seeing some blending of green and yellow here, and that would indicate that there were both Muslims and Jews in that area there. So it's a nice map. It shows a lot of detail, and in this case, one dot equals one person. Once again, though, remember they didn't actually identify where a person was standing and put a dot on the map for them. They took larger enumeration. They took larger units where things were measured. They found out how many people lived in that area, and then they found out what percentage of them identify themselves as a certain religion, and then just randomly distributed those dots around the area. And we can see some of those areas with lower numbers because they stand out here, but areas with higher numbers tend to blend together, and the whole map looks pretty continuous and an interesting way to represent all these different religions.